Let's take a look here at example number 1. We want to determine what type of conic section is represented by this equation. And then we want to provide a rough sketch of what the conic might look like. Okay, so this is obviously not in the shape or in the form of any of the previous conics that we had talked about. And so what we're going to see is that one of the most important things for this particular section is that we need to be able to complete the square to try to convert this equation into something that's a bit more usable. So we'll start by writing here, we need to complete the square. And let's see how we would actually do that. Let's see, I'm going to have my 9x squared, and I'm going to try to bundle this together with all of my other x terms. And I'm going to leave some space to add in some new mystery value to help complete the square. I'll do the same thing with my values of y. So I have a negative 4y squared. I have a positive 8y. And I'm going to imagine that I'm going to be adding something to this to complete the square. I'm going to shift everything without an x or y over to the other side. Now remember, in order to complete the square successfully, you have to have a leading coefficient of 1 in each of these parentheses. So in the first one, I'm going to be forced to factor out a 9. In the second one, I'm going to be forced to actually factor out a negative 4. And I don't really have to change anything about the back values because I don't even know what those values are yet. Now on the other side, again, nothing has changed because I haven't made any modifications. Now I have to think, though, about what value I would want to add into here in order to complete the square. Remember that the standard way of doing that is to say that if this is the value b, then the value in here should be b over 2 all squared. So this would be negative 4 when cut in half, and when squared, I would be interested in adding in 16. So notice if I was to add in a 16 here, what I've really done on this particular side is I've added in a 9 times a 16, which I believe is going to be like 144. That's what we've really put in here. And so to counterbalance, we're going to have to go ahead and add a 144 to the other side. Now I'm going to go ahead and actually do this right over here by saying I'm going to add a 144 to balance this. Similarly over here, if I chop my b in half, I get negative 1. Squared, I get a plus 1. But of course, it's not really just a plus 1 that I need to counterbalance with, because when I distribute, I'm really going to see I'm going to get a negative 4 here. So of course, then I'm going to have to put a negative 4 over here to keep everything balanced. So now I can go ahead and simplify this down. I'm going to get 9 multiplied by an x minus 4 squared, and then I'm going to get a minus 4, a y minus 1 squared, and on the other side, I believe if I simplify that all the way down, I'm going to end up with a negative 36. So hopefully you can see I'm getting a little bit closer to one of the shapes of the conic sections that we've seen before. It looks like here I actually might be working towards a hyperbola, which we talked about at the end of the last video, because I know that I have this minus sign between two quantities that are being squared. But for every hyperbola and ellipse, we always had to have it equal to a value of 1. And so I'm going to go ahead and divide everything on both sides by this negative 36. Notice that when I do that, my y term is going to become positive, and my x term is going to become negative. And I think I'm going to end up with then something that looks like this. So when I look at this final equation that I have, I should hopefully be able to identify that this is indeed a hyperbola. So we got it. That's a hyperbola there. Now, if I want to go ahead and graph this, I'll have to think carefully about some of the different features of this equation and what they're really telling me. So first off, I can see that this is a hyperbola that's starting with a y term, and so I know that means it's going to open up or down. So if I was to go ahead and create a little graph paper here, oops, let me try to sketch this out. That looks terrible. Sorry about that. There we go. All right, so if I was to go ahead and create this, I could see that I'm going to first have parabola type shapes that open up and down. But I'm also going to see here that there's a center to this parabola or hyperbola that's going to be occurring at 4, comma 1. I can tell that because my x has been shifted by 4 and my y has been shifted by 1. Just for the sake of argument, let's just suppose that this is my point 4, 1. Now, if I wanted to go ahead and sketch out the rest of the picture, I have to think about my shift. Notice here that my value of a is 3 and my value of b is 2, because 3 squared is 9 and 2 squared is 4. Now, if I want to get to these vertices, I would have to go up 3. So let's imagine going up 1, 2, 3 and down 1, 2, 3. And these right here would be where my hyperbolas would begin to start. So I'm going to have some sort of parabola-like shape opening up here, and then another one opening down here. Now, to see the full picture, what I can actually do is also utilize this value of b. If I move 2 units out in either direction from the center to get these points, I can actually go ahead really quickly and create a little box that kind of encloses all of these points. And this is a very standard way of attempting to graph a hyperbola. What we'll see is that if I actually connected a dot through the corner, or a line through the corners of this rectangle and through the center, these form asymptotes of the picture. And then I can go ahead and actually sketch the corresponding hyperbola as it becomes asymptotic to these particular lines. So this is my standard way of sketching a hyperbola, and hopefully it's not too hard to follow. Again, I use this value of b, which was in the x direction, to move out from center. I use the value a to move up and down from center. And then I created my box. I had asymptotes that go through the corners, and I just sketch out my little parabola-like shapes. So that's it. That's example number 1. And for questions like this on exams, this is all I would expect that you're able to do. Can you identify the equation, complete the square to possibly get there, and give me a really rough sketch of what the shape might look like?